All right. Okay, so good afternoon. Thank you for coming to my talk. So today I'll tell you a bit about how we design and develop the Flix programming language. Okay, so in particular, I'm going to tell you about two things, the design values and design principles of the Flix language. And so what are these? Well, I think of them as a social contract. So this is a way of writing down what programmers can expect from us as language designers, and what we as language designers can expect from programmers. So today, you might think that I will be talking about good programming language design, but I'm not sure that we are just ready to answer that question yet. So instead, what I'll actually be talking about is a principled or systematic programming language design. Okay, so before I get started, I just want to give you a very brief introduction to the Flix programming language. So in a nutshell, in one slide, Flix is a new functional, imperative, and logic programming language. The goal is to offer a unique combination of features that do not exist in any other language. It feels like a blend of Scala, OCaml, and Haskell. It has many features that you would expect from a functional language, including algebraic data types, pattern matching. It has functions, higher order functions, parametric polymorphism, and so on. Notably, it has a few unique features that are not found in any other language. For example, it has a polymorphic effect system. It has something we call purity reflection. It has local region-based mutation, and it has first-class data log program values. Okay. Now, if you want to know about these features that I just mentioned, you can, of course, go look at our papers, and you'll find several of those. But the thing is that these papers don't really tell you anything about how we design the language. Instead, what these papers tell you is that they give small calculi that present also a type system, properties about that type system. But they're really very focused on a specific aspect of the language, and they don't tell you how everything fits together. So how is Flix actually designed? So this is where the Flix values and design principles come into play. So I've tried to define what I mean by value, and I'll just read it here. So value in the broadest sense is a subscription to a particular view on how programs should be written. A value in a more concrete sense is a property of a programming language that its designers consider to be important, worthy, or useful. So value is kind of a nebulous thing. It's just a view on how programming should be done. So you could say it's aspirational. So the Flix values are sort of things we aspire to have. On the other hand, a principle is a design guideline. It expresses a particular property or collection of design choices about how something should work. And the goal of a principle is that it should be actionable and, most importantly, falsifiable. So we should be able to determine if a principle is satisfied. So once we formulate these principles, it will be possible for someone to look at a principle and say, well, does the Flix language satisfy this principle? To compare to another language, does the Java language satisfy this principle? And so on. Okay, so where do these values and principles come from? Well, they sort of emerged out of discussions we had over the last 5-6 years on GitHub. So whenever we are designing some part of the language, inevitably discussions would arise, and we had to come up with a set of design choices. And what happened was we started writing down sort of the summary of these discussions we had. We also looked at other programming language forums, and for example, the OCaml discussion website, Scala contributors, and Rust internals, to see how did they design various aspects of their language. And then writing these things down, we at some point decided to start posting them on the Flix website to sort of keep everyone honest, or to have a central place where these things were written down and you could reference them. And so the purpose they really serve today is as a mechanism for what I think of as consensus building and conflict resolution. So for example, let's say there is a feature request and someone has made a pull request with some new code, and we do code review. Well, when giving feedback, I have found it to be much more useful to be able to point to some principles saying that, well, this is what we want the language to be, and maybe this code has to change to satisfy that. This is much better than just me saying, for example, well, it has to be like this because I said so. Also, it often helps separate technical discussions from language design discussions. So in particular, we can separate sort of what is an implementation detail from, oh, okay, here's something more fundamental going on, and we need to consult the principles. So here they are, shown on the Flix website. Let's first talk about the values, and then we'll get to the principles. So the values, if you remember, those were sort of the things we aspire to be. And so I put all the values here. I'll not go through all of them, but I'll just talk about a few to give you a flavor of these aspirational things. So one value is that we want to be a functional first language. And that means that Flix is at its core a functional language that has elements of imperative programming and logic programming. Now, whenever we expand on, let's say, the features of the imperative part of the language, the point is we must never sacrifice the fact that the functional part is the most important part. So this helps us when we make design decisions to see, well, if this will somehow compromise the functional design, then we shouldn't do it. Another value we have is that Flix should be one language. So that means there should be no compiler options, no compiler flags, no compiler plugins, nothing like this. There's always just one language, and we have to design it as best we can. We also have two more values here: productivity over performance and correctness over performance. And so productivity over performance means that we are okay to sacrifice some runtime performance if it means programmers can write programs faster. So I think that's true for any high-level programming language, really, because of course you can get maximum speed if you write in assembly code or something like this, but if you want to help the programmer write more software, well, then maybe you sacrifice some machine performance by having abstractions. And correctness over performance is similar. So it's saying that if there is ever a choice, we want to err on the side of being cautious. So for example, C is a low-level language that really prioritizes performance, but things can go horribly wrong. And so in Flix and like in Java, for example, there are certain checks done at runtime to make sure that things don't go completely wrong. Okay, so these were the values, and they are not really something that you can easily judge. Like, does Flix satisfy this principle of being functional first? Now we get to the principles, and these principles, the goal here is that they should be testable or falsifiable. So you should be able to look at a principle and say, are we living up to it? Now, just to tell you a little bit about what you can expect in the paper. So each principle has a name and it has a short description. Then there is a rationale that explains what is this principle about. Then there is the discussion that talks about how has this principle affected the design of Flix. And finally, for some principles, there might be a hypothesis, which is actually like a conjecture we'd have that someone could perhaps go out in the real world and experimentally validate. So in total right now, I believe we have more than 40 principles. Of course, I'm not going to go through all 40 principles. Instead, I'll just sort of pick two from each of these categories and talk to you about them. Most interestingly, at the end, we'll see that there were also two principles that we had established, agreed on, written down, but then later found out that we could not live up to. Okay, so let's dive in. Let's talk about syntax first, because that's something that's always debated widely. So we have several principles guiding the design of the syntax, but I just wanted to show two. So the first one is principle 3, keyword-based syntax. So this principle says that the syntax should be keyword-based. So that means we should have words, and ideally there would be 3 letters to make sure that the programs look well aligned. So I'm just taking an example here. So in this small program, we have the use keyword, the def keyword, and the let keyword, and they're all 3 characters. So that means we get a sort of nice alignment when you format the program. We also have another principle that says that the term and type level syntax should be mirrored. And what does this actually mean? It means that, for example, when we write function application, we write it like this: f applied to ABC. But when we write type application, we write it almost the same. Here we use square brackets. If you were to write a lambda expression, we write something like this: x goes to x plus 1. Well, the type of this lambda expression is int32 goes to int32. Similarly for tuples, you write them like this, and their type are like this. So you can see that the expression syntax is sort of mirrored in the syntax of the type. And this means that the programmer has to sort of learn less syntax to use the language. And also the language feels more predictable. Now, for example, when we were writing this principle, or actually revisiting this principle, I discovered that we were using this syntax for records with the equality sign. But at the type level, for no good reason, we had actually used colon. And then as I was looking at this principle, we decided to change that so that the syntax became more consistent. Okay, let's talk about the static semantics. So one very important principle we have is that Flix should separate pure and impure code. So this means that if you're a functional programmer and you write pure code, well, the language should know that and support that. And you should be able to trust that if something is said to be pure, it behaves as pure code. So concretely, the way this happens in Flix is that it has an effect system. So if you were to write a function like sum taking 2 arguments, well, there's no effect, so you know this is pure. It behaves like a mathematical function. On the other hand, if you were to write a function like say hello, and you were to print to the screen, well, this would have an IO effect. So now the type system would know, the effect system would know that actually here something effectful is happening. And this sort of pervades through the entire language. Another principle about the static semantics is that we have a type system and we have type inference. And our goal is that we should have what I call complete local type inference. And that means that you are required to write the top level signature of a function, but then inside the function, all the types should be automatically inferred, like in ML or Haskell. And this means that if you get a type error, you can know for sure that it's because you've made a mistake in your program. It's actually a real type error. It's not because type inference is too weak. Now you might say, okay, why do we then require top level declarations? After all, let's say OCaml, you don't have to write any declarations. But actually, it turns out to be a very useful and pragmatic choice. So by requiring you to write type signatures, you tell the compiler, well, this is what I expect this function to take as input and give us our output, including its effects. And this allows you to more easily assign blame. So, for example, if you call a function and you pass arguments of the wrong type, then we can blame the caller. Or alternatively, if you write the type signature and the body has a different type, then we can say, well, the implementation of the function and the signature are mismatched. Finally, it also enables us to have parallel type inference, which is very nice. And in practice, I think people write code like this anyway. Even if there was global type inference, people tend to put some annotations or comments at the top level declarations. Okay, let's talk a bit about correctness and safety, some of those principles. So one principle we have is that there should be no warnings, only errors. So this is actually a principle that Flix shares with Go. And the idea here is that warnings can be ignored or turned off, right? And so how can you know if a warning is really serious or not? And this is, I think, in my mind, really sending mixed messages. If you get warnings, how are you supposed to know what steps you should take now? Every time I use a JavaScript and NPM, I'm told that many libraries have some vulnerabilities, but I have no idea if they impact me or not. I also think it's a bit sloppy to have warnings in the sense that it pushes the burden on the programmer instead of on the language designer. So in Flix, and I guess in Go as well, it is up to us instead to always decide this is always wrong. It's a hard error and it involves compilation. You have to fix it. Or alternatively to say, well, this is always okay. There's not some middle ground with some warnings. This behavior is completely fine. Another principle we have is that Flix should have no global shared state. So this just means that there is no global mutable data or anything like that, no static fields. In particular, the way it's enforced is that we have a region-based memory system. So if you want to have mutable memory, you have to put it into regions. And those regions always have an associated scope. And then the effect system will track how these regions are used. And that means that the closest thing you get to global state would be in main, you could declare a new region and you could declare an array. And then you could, of course, pass this array throughout the program. But now it's very explicit that a function is taking some mutable memory and it belongs to some region. So there's no sort of hidden global state. Right, just to show an example of how the effect system does this. So if you have a function reversed that can reverse the elements of an array, the array will, of course, have a type of its elements, and then it lives in a region R. And then for reverse, we know that it performs a read in the region R and also a write. So that means when there's a mutable memory involved, we can see how it's accessed by every function. Another principle we have from Go is Go. So in Go, it's not called a principle, it's called a mantra, which is do not communicate by sharing memory, instead share memory by communicating. And the way this comes to fruition in Flix is that processes should always communicate over channels. And in particular, if you want to share something over a channel, it has to be sendable. And so today that means it has to be immutable. So we're not quite there yet. There's one thing we still need to resolve, which is that you should not be able to capture mutable memory. But ultimately, this will mean that we will be in a place where you can have multiple processes, but the only way they can talk to each other will be by immutable message passing. And this will be enforced by the language. Another principle we have is that we should not confuse concurrency with parallelism. So of course, it's important to have both concurrency and parallelism, but it's important to have support just for parallelism, which I think of as when you have a programming task and you have a trivial way to break it into parts that can be executed on multiple processes, but in some sense there's no communication or anything like that going on. There's no ordering issues. And so to support this, we have a specific parallel construct. So let's say I have a function from A to B and I want to map it over a tree. Well, I can write this recursive function, and then I can use the part construct here to say, well, I want to map over the left part of the tree and over the right part of the tree in parallel. And when done, I want to combine the result into a new node. And so the point of this parallel construct is that it's sort of syntactically very lightweight. You don't have to worry about threads. You don't have to worry about channels. You don't have to worry about message passing. And the types and effect system enforces that these expressions here are pure. So you know that evaluating them in parallel cannot cause any kind of races or deadlocks or anything like that. So this gives you a way to get parallelism without all the complexity of concurrency. Another principle we have, very much inspired by this value about being valuing correctness, is that Flix should do what it can to reject programs that contain useless expressions. So what is a useless expression? Well, a common mistake is you have something like this, where you call a function, check that the front door is locked, or maybe I should have said unlocked, and print welcome home. But actually, it turns out that this function here, it doesn't do anything. It just returns a Boolean, has no side effect, and you discard the Boolean. And the point was really that to have used this function correctly, you should have asked what is the result, and then you should have branched on that. And so this kind of useless code we can detect much better than most languages because we have this effect system. And then we can enforce that every expression at least does something, so that you don't sort of mistakenly forget to use return values and things like that. Two further principles in this direction is that we require that you have no unused variables and you have no variable shadowing. So for example, I've found that it's very common that if you do a bit of copy pasting, sometimes you forget to adjust the variables. So for example, you might have a function sum here, but you meant to use y down here, but you copy pasted something and you don't see it. Well, Flix will compile about that and prevent your program from complain about that and prevent your program from even compiling. And in fact, there have been some studies in the research literature that show that when you have buggy code, often near that code, there will be sort of elements of redundancy. So I think this is also a way of avoiding some stupid programming mistakes that otherwise would take quite a while to find. Then we have some principles that talk about compiler messages. So we spent a lot of time discussing this one, basically agreeing what should even be in a compiler message. So we have a principle that covers that. Basically, a compiler error message has to have a one-sentence summary. and that's what we show when you hover over it. Then it has to have a multi-line piece of text to give all the relevant information, so the program symbols and maybe a fragment of the source code. And then there is an optional explanation that you can turn on by asking the compiler to explain what is going on here. Another thing we worked on is that compiler messages should be quick to scan. So ideally, the first sentence or even the first word should give you exactly the hint you need to know what's wrong. And that's because many times when you're reading error messages, you will have seen the error message before. So you really just need minimal information to fix it. So in older versions of Flix, we would write like a sentence like the function foo is defined twice. But it's really the twice part here that's important. So you don't need to read all these words, the function foo, whatever. So it's better to say, for example, duplicate definition foo, because you might just get it to the word duplicate and you already know, oh yeah, of course, I copy pasted the function, so then I need to give it a new name. Another thing we looked at is that the style and tone. And one thing we learned from a very interesting paper by Becker et al. Was that we should avoid blaming the programmer for errors. So before sort of being compiler writers, we would often say things like, oh, this is illegal, or this is wrong, or this is incorrect. But it's quite strong language that's unnecessary. So instead now we try to say something like, oh, this is unexpected. We did not expect to see this. It's a bit more neutral. We expected something else. We don't put blame on the programmer by saying what they're doing is illegal. And we also have some principles that cover the standard library. So one principle says that every function in the library must be subject last. And that means that when you consider the order of arguments, the last argument should be the one that it operates on. And so, for example, if we have map here, it takes a function argument and takes a list. So the list argument should be last because this is the subject. And the reason it's important to have this is that this enables pipelines. And so by enforcing this on the entire Flix standard library, which is like 30,000 lines of code, it means that we ensure that all of our code will work with partial applications and pipelines. Now, of course, there are some corner cases. What about list append? It takes two lists, but which one is the subject? That's maybe not so clear. I think I'll skip this in the interest of time. And then lastly, I just wanted to talk about two principles that we had actually written down, but ultimately had to abandon. So one was we had a principle that there should be no blessed library. And the idea was the language should be completely separate from the standard library. In particular, this seemed like a good engineering choice, and it should allow someone to substitute their own standard library. But in practice, it's just simply too convenient for the compiler to know about the language, and for the language also to make certain assumptions about the library. In particular, today, the Flix compiler makes a lot of assumptions about the existence of certain type classes and how they look like. It also assumes that it can desugar the channel implementation to some Flix implementation and many other things like this. Finally, we had a principle that we had a uniform function call syntax. And that just means the ability to, if you have a function call like this, f of abc, then you can also write it as a.fbc. So this gives you sort of a object-oriented style. And we had this for quite a while, but actually it turns out it's ambiguous if you also add records to your language. And so we discovered at some point, well, does this mean that I have a record A and I access field F? Or does it mean I'm calling F, passing in A that just happens to be a record? It's ambiguous. And second, this actually really only works if your functions are subject first, but our functions are subject last to support pipelines. So we had to abandon this principle. So to wrap up, Flix is a new functional, imperative, and logic programming language. We are building Flix by maintaining sort of a living document of design values. So these were the aspirations, and design principles. So these are sort of testable design choices that we use to guide the design of the language. We hope that by writing these things down, it becomes easier to discuss programming language design and to compare different designs. Finally, Flix is open source. It's freely available and it's ready for use. So thank you. That concludes my talk. Yes, and I think, uh, as we're saying, some of these principles we actually stole from others because we would have to design a particular aspect of the language, and we might go to CEO Camel and see what design choices they made. And sometimes we would find these tickets with hundreds of comments talking about how they designed some feature, but ultimately many of these discussions ended with a specific implementation and code, but it didn't end with a summary of the knowledge that they had gained or what the principle was. And so what we try to do now is not just end with an implementation, but write down actually what was it we realized. Yeah, so taking the first question. So this thing where Flix doesn't allow your program to even compile if you have an unused local variable, or this thing where it doesn't even allow your program to compile if you have an expression that's not used, it feels very cumbersome in the beginning because it feels like the compiler is really getting in your way. Um, but I think after a while you get used to it. I don't know if that's the Stockholm syndrome or not, but the point is then that you can't really have a compiler that at one time ensures that the code you have is doesn't have stupid things in it, right? And at the same time allows flexibility, right? So it's a little bit like null. It's very convenient in some sense to have null, right? You can be like, oh, I have a student local variable. I'll just assign it null while I figure out later what its value should be. But if you permit that, then you open up that you could have code developed running where there are now some null values. And in the same way, if you allow unused local variables or expressions that have no effect, then that will end up in production code. So we know that can happen in Flix because those programs are illegal. Now, of course, okay, we also have to be pragmatic. So we have a keyword, I think it's called discard, that lights up in red. And yeah, it's not 3 letters, but yeah, okay. And that instructs the compiler that, okay, I understand that what I'm doing here is silly, but the compiler will then permit it. But you call out explicitly that this is useless. Now, for the second question, how do you extend the language with new keywords? I think that's very interesting. I'm not sure the best way to do it. I know it becomes a problem down the road, definitely. I think you could adopt that as that sounds like a hypothesis that you could check, right? Someone should do that experiment in the real world. One problem I would see is that I often think there's context when programming. So if you're writing a function, you have all the local variables and these things in your mind. Now imagine you write the function, you run, and it works, and then you work on another function, and half an hour later you push it to CI, and now it complains that this expression was useless. Now you have to restore the context. So that's why I personally think there shouldn't be two modes. There's just one mode. Now, of course, you still need a little bit of flexibility. So that's why in Flix there is this discard keyword, and you can also call variables with underscore if you want to say, I'm introducing this variable, I'm not just going to use it yet. So you can say like let underscore s some string, and then that's allowed, but you can't reference it. And then a little bit later, well, you can rename it not to have underscore. Now you can reference it. So there is kind of a story of how you write code even with these restrictions. I think it's a price to pay. I'll just say for imports, we actually don't do it because, and I'm not sure if we should, but it's because I don't think in Flix at least, an import could not make the program correct or not correct. An import is just a way of saying this name has a shorter name, right? But an unused local variable, well, that means that there is a computation going on that is redundant that the compiler could remove or not. I don't know, or if, so that seems more suspicious to me. Hello. With each other or just when we are building the language? That's a good question. I don't think we have. I don't remember the values specifically being in conflict, but I remember it being some interpretation of, for example, what does it mean to be functional first? Because there are degrees, for example, of functional programming, and so does it mean that you have to be functional programming or camel or functional programming completely like Haskell? Uh, so we've had discussions like that, but I don't think the values that we have now have. I don't remember them being in conflict yet, at least. But it's interesting. Yeah. Thank you.